Welcome to GER. Welcome to my class on Surds, my third class on Surds in particular. I shall be discussing my last subtopic in Surds in this class called equations in irrational form. So if you haven't subscribed to my channel, please subscribe by clicking the subscribe button and endeavor to turn on your notification button also. Please do well to smash a like on this video and drop a good comment on this video. You could also share this video to all and sundry around you in need of a video like this, and do well also to join my community on YouTube. Thank you very much. That being said, let's jump right into this video. So the first question is, what are equations in irrational forms? So equations in irrational forms are a type of radical equations containing Surdic components, having radicands in algebraic form. So please take note that we shall be discussing equations in irrational forms in this video, and I shall be looking at two things. My emphasis will be basically on two things. So the first question we are to answer in this video that I have just written down is, what are equations in irrational forms? They are a type of radical equation. What type of radical equations are they? They are radical equations containing Surdic components having radicands in algebraic forms. So please take note of that. For that reason, you could have examples of them as follows. You could have general examples of such equations, examples of equations in irrational forms. So let's see how they appear in irrational forms. Let's see how some of the examples appear. You could have an equation in this manner. A root bx plus c plus x equals d, where a, b, c, and d are constants. You could have an equation in this form. An equation in irrational form could appear in this manner. Please take note that this component bx plus c under the square root is what we call a radicand. Okay, so a, b, c, and d are constants, but under the square root you will find a component bx plus c, and bx plus c that finds itself under the square root is called a radicand, and the square root itself of bx plus c is a Surdic component, as we had described earlier on in our definition. You could also have an equation in irrational form appearing in this manner. You could have the square of a variable x minus a constant, say a, equals a constant b. You could have an equation in irrational form appearing in this manner. You could have it appearing in this manner: x, a variable, plus a, plus another the same variable, plus b equals a variable c. These are different forms. You could have equations in irrational forms. You could have so many of them. So guys, what are we to do in this video? I want to show you how to solve equations in irrational forms. Now that we know that equations in irrational forms are a type of radical equations containing Surdic components having radicands in algebraic forms. Okay, so you will notice that my radicands are all algebraic. Okay, they are all algebraic in nature. So how do we solve equations in irrational forms? I'm going to be showing you how to get that done. So let's start with solving an example. I'm going to call this example 1. So let's solve this radical equation: 2 root 3x plus 4 plus x equals 36. So my first step in solving this will be to make the roots the subject of formula in a way. So I'm going to say, in step 1, I'm going to take everything aside this to the other side. So I'll end up having 3x plus 4 equals 36 minus x. That will be my first step. The next step, which will be my step 2, will be to square both sides. So when you square both sides, you're going to have 4. The square of 2 is 4. The square of root 3x plus 4 will give me 3x plus 4. Okay? And on this other side, I'm going to square this side. Of course, what I'm actually doing now is this, so that you don't get confused. This is what I'm actually doing. I'm squaring both sides. So when you square this side, you end up having 36 squared minus the 2 times the product of the two of them. That is 36 times x times 2 plus x squared. Okay, now clearly this will give you the square of 36 will give you 1296, and this, when you multiply the 2 times 36 times x, will give you minus 72x plus x squared. You bring that down. So let's do this. On this other side, you have 4 times 3x, which is 12x, plus 4 times 4, which is 16. Now I'm going to simplify further. If you simplify further by taking everything here this way and leaving a 0 there, you end up having 0 equals, rearrange this other side, bring your x squared forward, and I'm going to have here minus 72x minus 12x when 12x comes over, and this one will become plus 1296, this minus 16. So this is the same thing as saying x squared minus 72x minus 12x will give us minus 84x. Okay, and if you simplify this also, 1296 minus 16, 1296 minus 16 will give you plus 1280, and that will be equal to 0. Now you could use any method that is convenient for you, but if you look at this critically, you can solve this problem using factorization method. Okay, the method of factorization. And looking at it, why that is easier for use is because if you think of two numbers that will add to give the middle term minus 84x, and think of those same two numbers such that in product they end up giving you 1280 x squared, you will notice that the two numbers that will do that, two factors that will do that, will be 64 and 20. So I'm going to put here, in place of minus 84, I'm going to put minus 64x minus 20x. Clearly both of them will add to give me minus 84x. Then I'm going to bring down this, equals 0. So the next thing I'm going to do is to factorize. X is common, I'm going to bring x minus 64 in one bracket. Then I'm going to take out 20 here. Minus 20 would come out, leaving me with x minus 64 when you use it to divide 1 to 80. So that ends up giving us 0. So this implies that x minus 20, x minus 64 will give you 0. Okay, so hence you can actually see that x will be equal to 20 or x will be equal to 64. Now that means that you could use your different values of x to find the solution or to confirm the solution of the problem. Now let's see. Now that we have solved for x, look at it clearly in relation to the problem. Now when x is equal to one of the things we obtained, 20, put x in place of that in that equation. When x is equal to 20, you will notice that 2 root 3 times x, which is 20 times 20 plus 4, then plus 20 again, should be equal to 36. So let's see, let's confirm that. So 3 times 20 is 60. 60 plus 4 will give you 64. So this will be 2 root 64 plus 20. Now what we are trying to do is just to confirm that our solution is correct. Now the square root of 64, take note, is 8. So 8 times 2 is 16. 16 plus 20 will give you 36, and that shows you that we were correct. So when x is 64, notice that you would have 2 times the square root of 3 times 64 plus 4, then plus 64. And 3 times 4 is 12. Pick one up. 3 times 6 is 18 plus 1, 19. So this is 192. 192 plus 4. 192 plus 4 will give you 196. So that is what you're going to have. Let's see. We want to know out of these two roots which one is the correct solution to that problem. So this will be 2 times the square root of 196 plus 64. And the square root of 196 is 14. So 2 times 14 is what you have here plus 64, which is certainly not equal to 36 on simplification. So it means that the solution to the problem, the actual value of x, is 20, not 64. So we will take this root as the root or solution to this equation in irrational form. Let's take example 2. Example number 2. In example number 2, let's look at the problem root x squared minus 7 equals 3. So to solve this problem, let's look at this problem. Root x squared minus 7 equals 3. Let's look at this problem. So what I'm going to do here is to square both sides as my step 1. So if you square both sides, you're going to have this. And that would mean the square of this square root will give you x squared minus 7, and this will give you 9. Okay? So once that happens, it means that x squared will be equal to 9 plus 7, x squared will be equal to 16, and x will be plus or minus the square root of 16, implying that x will be plus or minus 4. So x is equal to plus 4 or minus 4. Let's again check which is the preferred solution. So looking at it, when x is equal to 4, you have the square root of 4 squared minus 7 equals what? You end up having 16 minus 7, and this will give you 16 minus 7 is 9, and this will give you 3. So it means that x equals 4 is a solution to the problem. Also, when x equals minus 4, you would also notice that minus 4 squared minus 7 will be equal to 16 minus 7, which is the root of 9, which is also 3. So both solutions, both results are solutions to the problem. Okay, so they are both solutions to the problem.